I am making this live in Facebook as well. Also recording this. All right, so me. Oh, I hope you all can see my screen. With with some of the feedback, I'm going to go very slow because these concepts are a little hard to understand initially, but once you got it, you will not forget for life. So it's kind of, even if it is taking a little bit slow, I want to make sure everybody understand the concept. So I'm going to go slow today. And if you see, if I'm going a little fast, please put in the comment or unmute and tell me, I can slow down. Okay. All right. So today is the week 4 of machine learning. And the today's class basically is about classification. But I'm going to recap all the things we learned last 2 weeks, 2 or 3 weeks, so that you won't get lost with the new concept I am going to introduce. So basically, today's agenda is more about recapping all the things we learned last week. And then we will be going over a little bit on the linear regression last week we covered. And then we will concentrate more on the logistic regression. So with all the classes, previous classes, all we learn the basics of machine learning. And then we started jumping into supervised learning. And in that supervised learning, last week we learned about linear regression. And now we are moving into a logistic regression, which is a classification problem. We will have 2 more classes in classification, which is the supervised learning. There are 2 more techniques, one tree, the other one is SVG. There is another method, just like 4 of them we learn. And then we move into unsupervised learning, which is going to be totally another class. So the whole session, we are going to try to cover supervised learning and machine learning in general. And that's our main goal for completing the class. So next week, we will be covering that. And then towards the end, we will go through a recap what all things we learned. And then we'll do some projects together and then go from there. So even if you didn't understand anything, just try to listen today and you will get a hang of it. So today is classification problem, and the main class is about logistic, but we are going to recap all the things we learned last week. So last week we learned about, we already learned there are 3 different ways of machine learning: supervised, unsupervised, and the last one is semi-supervised, which is a reinforcement learning. So in our class is all about supervised learning, and we will have a second session on supervised learning, but our class, we were trying to complete the supervised learning. And in that, there are two types of supervised learning. One is a continuous target variable, and the other one is a categorical target variable. So in every learning, machine learning, the target is the one we are going to predict. So for example, whether this person has a blood, based on his blood pressure, height, weight, and income and age, we are trying to predict whether this person is obese or something like that, right? Or his BMI or any indexes, so we can find it. And the other example is a housing price prediction based on certain information we get. We want to predict the price. So those are kind of continuous target variable, because in the target, which is we are predicting the value, and that value is, it can go from 1 to 300 million, like that. It is not a set of value, but it is like any number it can go, right? That is kind of like a target, target variable, which is continuous. But in the categorical example is basically whether this is a dog or a cat, or whether the loan is approved, yes or no. Based on the value, we are predicting a certain set of target variable. That's what we call it as categorical target value. So based on that, there are two kinds of supervised learning we are learning. One is a regression, and the other one is a classification. Classification itself says, okay, whether you want to classify this as animal, this as human, or you are classifying this as, this is a certain value you are predicting. It can be these categories, right? But in the continuous variable, it just comes out with a value, which can be anything. You cannot say whether this has to be between this and that. So just wanted to give a brief overview. So you all understand, supervised learning. Supervised learning is all about teaching the model computer with the training data, and later is going to start predicting it based on the value. And supervised learning will have a target variable. Just keep it in your mind. In all supervised learning, you have a target variable which you are going to predict it. Unsupervised learning doesn't have a target variable. So this supervised learning, regression, and classification, we have a target variable. Okay, just keep it in your mind. Any questions? This is what we covered 2 weeks before, but I just wanted to make sure you understand that. Okay. So there are so many supervised learning algorithms: linear regression, logistic regression, support vector machine, and there's so many are there, right? So we are going to cover one linear regression, logistic regression, SVM, and decision trees. Those are the 4 things we are going to cover in our class. But in that, linear regression is our first one we covered last week. We are going to go over this again. And today we are also going to cover logistic regression. Next week, we are going to do the support vector machine and the decision trees. And the other 4, we can do it, in another class. We cannot get everything to understand that in a short period of time. So just, we will be covering those, but we will be covering the other 4 in a different session, like a class. Okay. So all are with me? Am I going fast? Just put a message here. All right. So I think we are good. So, so I just wanted to ask questions and people can answer it in the chat. What is, how do you say if there is a supervised learning or not? It should have one thing. What is that? Should have a target variable, right? And to become a supervised learning, it need to have a target variable. What is a target variable? Can anyone answer? Target variable is the one we are going to predict, right? That's what it is. So just keep in mind these two questions I asked. Just when you get the question, please answer it in the chat so I can understand you understand the basics, right? So the next question is, what is a data set? Data set, in a simple term, data set is a data which we are teaching a model, right? Data set is coming like a comma separated value or any kind of data we are teaching the model, it's called a data set. And in a supervised learning, when we have a data set, we have two sections, one features and the other one is a target, right? Features are the one we are going to try to teach the model with that feature, and using the target value, you are predicting it. Okay. So yeah, I want to give you time to, time to type in your answer. Thank you for mentioning that. Okay. So the next question is, now I have a data set called Boston housing data set. So in this model, what is your target? Looking at that, you can say, what is your target? We are trying to predict the price. So the last one, MEDV, medium value on our owner occupied, that is our target value. All others are, we are kind of getting those data from the data set. We are training the model. These are the features. Okay. So don't you agree that to teach the model, you need a data set? Yes or no? Yes. Yeah. So you need a data set to teach the model. Okay. All right. So now when we get the data set, first thing we need to understand or explore the data. You've been given the data set. You first need to understand the data a little bit more clearly. First of all, you need a target variable. If the target variable is missing, this is not a supervised learning. We already learned that, right? So make sure that you need a target variable to make this as a good choice for a supervised learning. So you need to know some of the statistical method to explore or understand the data. So a minimum you need to learn, you need to understand mean and standard deviation and little bit of percentile, right? So you already know what a mean is. Mean is an average, arithmetic average, sum of all the values and divided by the count. So that's the mean, right? It's pretty simple. So you can just find the average, for one of the tests, you want to see what is the class average. So you can just sum up all the marks and then divide it by the count of the students, right? That's That's the mean. Mean gives you a very good understanding of how the data looks like. But more than that, standard deviation is also a very good way to understand how the data is distributed. So the way the standard deviation can be calculated, it's pretty simple. What we need to do, you need to find the deviation. So I have a slide for that. So let me show you what it is. So this is a standard deviation. You can find it. So let's say 155 centimeter is the mean height of all those people. And you want to find the mean, everybody has different heights. The mean you are getting, the average height is 155 centimeter. That's, you already know, mean is pretty simple. But when you go to standard deviation, what they do is, what is the difference between each person's height to the average, right? Getting the average, and then square that value and sum up. And that is called the quadratic mean, which is a standard deviation. So which will tell you how the data has been, whether we get the right kind of data. We can eliminate some of the data which is not collected properly. So standard deviation is very important, while selecting which feature is we are going to accommodate in the model, where we are going to teach the model. So you understand that, right? What is the mean? Mean is the average. Standard deviation is the quadratic mean, which is the deviation of each element, each value that to the mean. How much deviated this person is, we are squaring. You know why we are squaring? Because some of them are minus. So in this case, this is -8. The second person is -8. Then if you are multiplying -8 by -8 is, then you get a positive number. So all we wanted to know is how much deviation it is. So that's you need to understand the mean and standard deviation. Once you understand that, everything is going to be easy. Okay. So when we started getting the data, we learned in linear regression, the best way to predict it is putting into a graph in the x-axis and y-axis, right? And you plot a graph and you see all these dotted line. Imagine that line is not present there, but there is a lot of dots are there. So now this is the data, we have it, the actual value. And now if you want to predict the number of customer is 45, you can draw a line and see where it lies. So in a way that you have to find or draw a line where each point on the other side, the deviation is much lesser, right? So that if you draw a line somewhere on the top, that's not a good idea to draw it, right? For example, I'm going to put this as an example here, and I will explain that a little bit in detail. So here in this graph, so let's say if I don't have this, I'm going to remove this line. Okay, no, I could not remove it. So so let's say I have a line which is coming like this. Okay, let me put that. I have a line, I draw it from here to here. Okay, sorry. Let me draw a line. I have a line like this. Is this a best fit line? Because it is not, because the distance between this and this, if you are adding up all the differences, it's going to be a bigger number, right? But imagine that this line between this and the line, it's going to be, when you're totaling up, it's going to be comparing to this line, this is going to be the less. So we need to find a line which is the best fit. Means you need to draw, if you're kind of drawing it in a graph, when you're drawing it and find the standard, the deviation, how much deviation, and if you sum up and then you get the best fit line with the r squared value, which is the distance between this to the corresponding line, is minimum. If it is minimum, then that means you have the best fit line. So in this case, that is what the model is kind of working on creating. So what it does is it do a regression, try different lines and see which line has the best fitting line where all these are near to that, right? So that when you try to predict it at under 70, you trying to predict it in this line, this is totally wrong, right? And the best value can be the one which is here, which is kind of near to that. So that's what the prediction. Sometimes the prediction may not be exactly correct, but it will come to the nearest value. So that's how the prediction is. So now you understand what the best fitted line is, and this line we got it from doing the linear regression model. Okay, so that's what I wanted to explain it. You all got it? So this is, we are talking about linear regression. Okay, some of the terms you need to understand here. I'm just going through this. We in linear regression, the one thing you have to keep it in mind, you need to have the best fit line. Okay, and the best fit line. Let me go to the next slide. So when you do the best fit line, how do you know whether this is the best fit line? Is inside the model, it calculates the r squared. So r squared, which we already talk about, how much the deviation is, you are squaring up the value, right? So finding the r square and finding the p value, which is the probability, which is higher probability. And then you can start predicting it. So in linear regression, first you need to understand that you need to have a best fit line. And when you have the best fit line, so the actual value you get, so you have a couple of lines as I mentioned here, and each one has its own r square. This has one r square, this has the second r square here. This has another r squared value, and this has another r square value. So, and see which r squared has the right one, so that we know that's the best fit line. So the model does it for you. You don't need to draw the line every time, but you need to compare which data is correlated more, right? That's what we need to do. So linear regression, so this is linear. So in linear regression, there are a couple of things you need to know. One, understand the mean and standard deviation. And we already talked about the best fit line. And then the r squared and correlation and the p-value. And I'm going to go through the example in the lab. And we will go over the Boston house pricing model, how we develop in the linear regression. So that will give you a very good understanding about what we covered last week on the linear regression side. All with me? Can I move to the next topic? Okay, cool. So in a linear regression, couple of things you need to keep it in mind. One, mean and standard deviation, and best fit line, r squared, p-value, and that's all. At least you need to know these words so that when you're working on a program, when you are taking a class in college, they will ask you, what is the R squared? What is the p-value? So you know that what it is. What is the best fit line? You got the best fit line or not? So those questions you can easily answer it. Okay. So we already covered mean and standard deviation. So R squared is calculated by 1 minus standard deviation by mean deviation. So that's the formula. If the standard deviation is less, then the line is a good fit. There are a couple of things you should understand. If standard deviation is less, then the R square is near to 1, and this is going to be more correlation. And a p-value is a probability and hypothesis. So we will go through an example so we can find it, how the best way we can find it. So in a way that the standard deviation should be less. If the standard deviation is less, the R squared is going to be near to 1. And p-value, the probability should be less than or equal to 0.05. So in this case, the second low R square, high p-value. So I'm going to explain this more in detail. So it is going to come in the lab. Okay. So now we are going to go back to the Boston lab. Okay. So let me get that in the Jupyter notebook. I have a program here. I'm just going to go through it. This is a linear program, and we have a data set called housing.csv. So housing.csv, we already saw there are 13 and 14 different columns given. In that, the first 13 are the features, and the last MEDV is the one we are trying to predict it. But you may wonder why they are giving MEDV here, because we are teaching it. If this is the value and this is the value, we are kind of predicting it. So just keep it in mind. So why MEDV is given? Because we are teaching the model, and then later you won't have MEDV because we will give all the other features and will ask you to predict it. So when you're teaching the model, you have to have the target value. But when you are started predicting, you won't give that the target value. You are supposed to find the value. Okay. These are the questions a lot of people having. Oh, when I'm teaching the model, why you are giving a target value? Because we are teaching the model, right? That if this is the condition, this is the result is. But later, once the model has been learned everything, the maximum number of records in here, we have given 506 different instance of data, and also it has the value. So it's able to learn from 506 rows. The more rows and the better data will get the accurate result, more accurate result. So in the model, when you're creating a model, in Jupyter Notebook is basically a tool to collaborate and create a program. So more than one, in a team can start working on it, building a model, because more collaboration can happen in Jupyter Notebook. So the first thing you need to do in the Jupyter Notebook is first you need to import some of the libraries. So we are using some libraries to collect the data and do some research. So the first thing we need to do is importing those libraries. So the main libraries we are using is NumPy and Pandas. So these two libraries are very good in trying to find the mean, medium, all those things are available in those libraries. So in a way that NumPy and Pandas are kind of serving the same, but Pandas is being used more because it has more functions available. And NumPy is, pandas can do, if it is a million records, it can handle better than NumPy. But both are, good libraries been given. And sklearn is something like a library for us to, it has its own model libraries built in, like a linear, logistic, all those model created. So you can just call those model and then fit the data into it. So there's a lot of things, sklearn, we can take it. Matplotlib is like when you want to draw a graph or something, we can use that. Seaborn is another kind of graphical tool, we can use it. So the first thing is you need to import all those libraries and you need to give a nickname. So you all understood that, right? In any model, when you're writing a program, first you need to have those library need to be loaded. So you can just click next. So it can, these are kind of called cells. Each cell you can execute by going into the cell. You see the green line on the left side, you can click run. Okay. So the next step we are doing is, the next step is what? We have been given a data set, right? Housing.csv. You know what a CSV extension file is? It is nothing but a comma separated value file. You can open this in Excel. Most of the time you will be given .csv. It's like a text file. You can open in Notepad, but a bigger file, it's going to be hard to open in Notepad. And we are loading that CSV into the memory, loading the data into the model, right? So when you say data.head, it will tell you the first 5 rows of the data. So we have 0 to 13, means 14 features we have, columns. It has been loaded and it shows the first 4 rows. So that you understand that, oh, we loaded the data is fine. So let's say if there is an error, this will not show all the 5 rows here. So this is just to make sure that we have the data loaded. Then you are assigning the column name, because now it is with no header, right? So now we are assigning our own name for the columns. So each column name, we can put it into a list and then assign that column name to the data set. So here, once the data has been loaded, data is the data set here. You can even name it to housing data equals, you can do that. So then you will be starting using housing data.head and everything goes to it. This is like a variable, right? But that is the data set we loaded. So the next thing, it's very important when you're doing a model, you need to see the data. We already look at mean and minimum, maximum, standard deviation. That gives you a very good understanding that even though they give this many features, which feature is really helpful to predict the price, you will be able to understand from those values. Looking at the mean, looking at the standard deviation, you can understand how the data is distributed, especially. So for that, you can just say the data which is loaded .describe include all will give you all the statistical value method it will give you. So that gives you an understanding about the data. Then you can go and, okay, the standard deviation which is less, maybe a better one. If it is too high, it may not be a good fit for predicting. So then you are selecting the feature. Out of this 13, we will eliminate, okay, this 5 or 6 are not even related. We don't use it for predicting. So that is why. So this is called a data exploration. Later, we do a plot diagram. So how this is being distributed. For example, the data is distributed like here in this model, how the data is, whether looking at the graph itself, you can say whether it is, this one is a good fit. See, this goes up. Based on that, you can find, okay, this room is the one which is linearly looking at the data. You are able to have a best fit line. Can you do a best fit line here? No, because it doesn't, it's all coming into the left side right here. And then if you look at the tags, whether the tags will give you some, because it's all coming one chunk, you cannot draw a best fit line, right? But if you look at room, let me see, room is the one. You can see how the value is distributed. So you can find that, you can find a best fit line and you can start predicting it. So this plot diagram will tell you how the data is distributed. Based on that, you can select which column is really good. So now we are going to do the study for, differences between the room and the crime rate. And you can see how the data is distributed. You can find out how it is. So based on that, we can say, oh, which is the feature I am going to use it for training the data. Okay. The other thing is very important is correlation. So which data is correlation? Correlation means which data is very much related to the target value. Here the target value is MEDV, right? So you can have a heat map and see which one is near to 1, this color, which one is near to 1. And then you can see, in this case, you can see 0.7 here, which is a room, is having a higher correlation. And but looking at all of them, other things are all, you should not use this one, because the price to price is always 1-to-1 ratio, right? So you are using, some of the value which is correlated more with the price. So we kind of take room as in this example. You can change the heat map, the way you want. The whole red is the most, correlated. You can change the color scheme, but this is the default color scheme they give. So now we are looking more. So we look at all these things. So we selected 1, 2, 3, 4, 5 of them, and then see these columns, how they're correlated. So then we can see more detail. Okay, this is a good room, is the best, correlated, because it is coming near to 1, right? 0.7. Once you have that, the exploration is done. So we kind of selecting room as our feature. All other columns are not really relevant from the pricing prediction. So we use the X axis. There are 2 values. One, we are using to the feature which is using for prediction, which is a room, and Y is going to be the value we are going to predict it. So we say X is equal to room, all the rooms are put into X, and then Y has all the predicted value. And then this is what I am saying, that sklearn is a library where you are loading a linear regression. That is a regression which is kind of finding best fit line. The program does, internally it goes and draw all these things and find the perfect fit line. So that's what this linear regression is. You are creating a linear regression model, and we are fitting the model with the value. X is the one which we are going to use to predict it, and Y is the target value. So we are, when the model is under fit, that is where it goes and find the regression mode and find the best fit line, right? This best fit line is this. This is the one we kind of looking at, right? So so basically this one, this line, the red line, right? So it will understand, oh, what is the best fit line? Okay, when you do the fit, and then we find the coefficient. So how what is the coefficient which is going to give you the the accuracy, looking at how what is the coefficient of that model, and then you are drawing the best fit line from the plot. So in this 506 rows, we are able to draw the value, but looking at that, using the linear regression, it is able to find the best fit line. You look at the line, and now you can start predicting, okay, if it is 6.5 rooms, what will be the price? So you can find the value, so we can predict the value. So you can try this linear regression by yourself. This is one example, Boston model. There are so many different data sets. We can kind of look through the same process, but the only thing is the different data set will have a different features. So just look through, do some exploration, find the mean, find the R square, and find the correlation. All those things you can try yourself. This is what we learned last week, how you can create a linear regression model program. So this is you have been given a housing price model, like the data set. You are training the data, and then you are going to start predicting the price. All right. But this model sometimes get outdated, then you may need to teach the model again. Okay. Let me see any questions. Okay. Okay. All good? Am I going fast? All right. So this is what we kind of covered last week on creating a linear regression. So linear regression, one main thing is the target value is continuous. It can go 1, 2, 3, any number, right? Now, with linear regression, you know how the best fit line, the R squared, and the p-value, all those things are important. Correlation is important to find the feature, which one you need to predict it. Just keep registering those words in your mind, and then you can go to YouTube, just type linear regression. There's a lot of things available. You can just watch it. Keep updating what you, and with all these numbers or words I talk about, this will come to life that, oh, this is what they are talking about, right? So just go and watch other videos, but this is good enough for you to start writing a model for a linear regression. I have uploaded this into our Google Classroom. Let me show you. Classroom. Let me go to Classroom. Okay, so the Google Classroom, I put that in the classification. There is a lab in linear regression. This is a program, and this is the housing data. This is a data set, and you can use it to start looking at. And I encourage you to find another data set and then try to do the same prediction, exactly how the Boston, this program, pricing model we did. You can try yourself and start predicting it, right? So that is the linear regression. So we are moving into logistic regression. Do anybody have any question? Supervised learning, continuous target variable, linear regression, we did the housing price prediction. Now we are going to the classification. Can I move to the next? Give me a thumbs up. Deja, are you following? You can unmute and say.
Yes, yes.
Yeah. Aryan, good? All right. Yeah, I got all the responses. Yeah, good. So now I'm going into logistic regression. So logistic regression, I said the target value is not continuous. It is a categorical, like whether it's a dog or a cat or yes or no, or predicting a certain value. We know these are the target value supposed to be, whether it is 0 to 9 or it is a dog or a cat or animal or human. Kind of like, whether cancerous cell is, whether the cell is cancerous or not, like that. So that is where the categorical, the classification problem, categorical values. So you understand the difference between the linear and logistic regression in a minute. So logistic regression, basically, when you do the linear regression, it goes like a straight line. It is going into one direction, going to a particular pattern. But here in logistic regression, it becomes like, there is a lot of value goes between 0 to 0.5, and from 0.5 to 1 is another group of value. So then you can say all under 0.5 is no, and 0.5 to 1 is yes. Or below 0.5 to 0, between 0 and 0.5, it is cat, and then 0.5 to 1 is dog, right? So this is called, logistic regression. It's like an S curve, So after a certain period, it started going into the another. So, between 0 to 0.5, there are some animal just not exactly look like a cat, but then slowly started going look like a dog. And then after some time, it's become totally a dog species. So it's called a sigmoid function, right? Where you are finding the value and then you find the log and make the value between 1 and 0, or 0 to positive infinity, or 0 to negative infinity, something like that. So you can have two distinct values. Understand that? So this is called an S curve. In logistic, in a linear regression, it's a line, best fit line, right? Okay, so logistic regression basically is like a S curve. We already talked about it. Example, the one which is going 0.5 and above, or dog, or 0.5 and below, or cat, or loan approved can be 0.5 and above, or approved 0.5 and below, or not approved. So we can just kind of coming out with a logistic regression algorithm. So this is called a sigmoid function, the S function, we use it. And I will explain a little bit more about coefficient. So the sigmoid function, if you are learning more in the mathematical way, this is a function. There is an activation function. Based on the sigmoid function value, always the y-axis will have a value between 0 to 1, or 0 to negative infinity or 0 to positive infinity. So you will have a distinct value between going there. Okay, so we don't need to go too much deep into it, but later we'll come back and learn what exactly it is. So in this case of differentiating two animals from a picture, we have like so many different pictures available, and one second. Hey, Limbo. Hey. Sorry, somebody called me. So in this case, we find the value, which is a sigmoid function value. It gives you 0.1, 0.3, and then 0.5, 0.7, 0.9. So you see all of them greater than or equal to 0.5 is cat and less than 0.5 is dog. So that is how the classification. We use the sigmoid function behind the scene. Linear regression, we use the best fit line, right? Like that. So the linear regression versus logistic regression looks like this. See, it's a line going up, and the sigmoid function is kind of an S curve. So that's the two. Looking at the linear logistic, you can understand how this is. So looking at the S curve from 0 to 1, the value like a weight, when you graph it, using the sigmoid function value, instead of putting the right value, we put that sigmoid function value. It always related to 0 to 1. So whatever is coming between 0 to 1, and when you draw the line, it comes exactly like an S curve, kind of like a S-shaped curve. But if you look at the middle part is where the confidence level is less, but towards the right and towards the left, we get more confidence that, oh, this is a particular species, or yes, answer yes or no. Okay. So one more, coming back to, when we are learning linear and logistic regression, you don't want it to confuse yourself. But that is why I keep on showing that between these two. So linear is like this, and we are trying to find the best fit line, reducing those, distance between the point and the, best fit line. That's our main goal. But here the sigmoid function, the curve with the maximum likelihood is selected is that becomes the best fit line for the sigmoid, like logistic, whether it is obese or not obese, right? Because it is categorical. So we have two categories here: is obese or is not obese. Do you have this here? We are just finding the value. Size can be any number, right? You are predicting the size based on the weight. You're predicting the size is like it can be any number. There is no categorical value, right? Here, there are two categories here. So just one more time, I just wanted to explain. So the logs of odd, so this is one of the things we need to keep it in mind, how you are finding the value and how this become S curve, because the log of the probability divided by 1 minus probability always give you a value 0 to 1. So when you learn about logarithm table, it gives you to the power of 10, sometimes it power of 1. We can say the value is standardized to that value. So that is what the log does. And that log function is the one we use it for sigmoid functions, because you want to see how it is. See the best fit curve, it's called the best fit curve. The other one is best fit line. So let's go and look at one of the lab, and logistic regression lab. And once I cover that, I will open the floor for questions, and you can ask any questions if you don't understand that, and then we can learn. Don't think that you will get a grasp of 100%, but at least 60 to 70% you understood what it is. That's good enough, but we can just keep learning more and it will get the foundation straight. Okay. So one of the lab, I'm going to show one of the example of a logistic regression. There are two labs I'm going to show. One is just a simple problem with a number game. And the next one is kind of like a handwritten, like we are going to teach the model a different way, writing the number like 2, writing in so many different ways, right? In this case, right? And the model will learn that. And next time somebody put a, when you're taking a picture of somebody write the 2, it can predict whether it is a number 2 or not. So it can predict whether it is 1, 0 to 9, any prediction. So let's start with the first lab, and then we can go from there, right? All right. So I'm going to go into the logistic regression, and I'll explain you. Again, in all those model, one thing you understood is first you load the library, second thing you load the data, and third one you are creating the model and you are fitting the data to the model and start predicting it. Once again, first thing is importing the library. Second step is uploading the data set. The third is creating a model, then fitting the model with the data and start predicting it. 5 steps. All got it? We did the linear regression also the same way, right? Okay. So in the library, the minimum you need to know about, we already know NumPy, Pandas, Seaborn. Those are for the plot library. Those are the ones you use it. I also uploaded some of the Pandas and NumPy and into the Google Classroom. Thank you to Narsi. He found a place where it gives a lot more information how you can use Pandas and NumPy and different functions. We'll cover that in another class. So for now, you just go with what the library, we are importing the library. So first we are using those libraries. You are just starting the library. And then the next thing we are doing that, I did, instead of that, we can just do a data set in the second place instead of this, but both are fine, right? So you have a model, we are using a logistic regression, and you are loading the data. We are hard coding the data here. We have the X and Y and 0 in this case. So look at this data set equals minus 2.0011. That is the feature value, and this 0 is the predicted value. So you can say this is X and this is Y. This is X and this is Y. X and Y. X and Y. So how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 rows. We are just putting as an array here. You can also put it into a CSV or a file, CSV file, and load it. But in this example, we are having only 9 rows, and then we are trying to create the model to fit the data, right? We have a data set. We can ignore this for coefficient for now. So the X is the first 0.211, 0.1.4564, 0.06965. Those are all the X array. So we have 2 arrays. One is the X array, and Y is the second one is the Y array. This is the target. Y is the target always. X is where we are using to predict those values. So if you look at the Y, either it is 0 or 1. So that's a typical classification, like a categorical problem, like a classification problem. So the next thing is you are creating the logistic regression, and you don't need to worry about this parameter right now, but that we will be learning a little bit more. Just use this logistic regression, and you are fitting the value X and Y into the model, into this model. So which is the model we created, logistic regression model. And then you start predicting the X value, right? So now when we fit the model, when we turn the model, we want to see how the prediction is, right? So when you do X prediction, it's going to give you all the Y value for sure, because we already teach the model with the answer, and it's going to give you back the predicted value for sure, right? Because that is how you teach it. But when you give a different set of value, it can predict it more clearly, right? So when you do the probability, once you start the model, once you fit the model, you can see the probability, how the probability is. So there are two things it will show you. The first element is basically a probability, right? That 98% probability or 99% probability is there that this is the value is going to be right. So it will give you some probability. But when you see the fourth or one, when it's between this and two, when 0 becomes 1, that is where the confidence level goes little down, because the S curve, when it started curving, that area, the confidence level is little bit less. So that will give you some idea whether how much confidence you can say that this value is right. What is the probability of getting the answer right? So once you start fitting the lane, then you can start predicting it. So now, once the model has been created, now you can start predicting, okay, what is the value of 0.8? The 0.8 is 0. The value is, it's predicted as 0 because this is a question we are given. So the model already taught with all the value we have. Now we started predicting it. So when you start predicting the value 0.8 is 0, but when you go to 2.4, it is 1. So let me go to 2.3. Okay, I need to run from the beginning, so that's why. After fitting, okay, 2.3, 0. But when you do 2.4, yeah, 1. So between 2 and between the value 2.3 and 2.4, the S function started going to the other territory, right? So when you look at that, you see the value near to 2.3, you will start seeing, let's say 2.3, see 2.3. So you will start seeing the confidence level is 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So you have a less confidence, 0.32% confidence only, because it is started curving. So during the curve, it's the confidence level goes down. Just want to give you high level. I also uploaded this into our Google Classroom. Again, one more time, you are importing the library, you are uploading the data set, and you are creating a model. This is the model you created, and our model name is CLF_LR. And then you are fitting the model with the X and Y, and you started predicting it. And you see the probability, and you start predicting more values. So once the model is created, you just give it to other developers to incorporate that model into a website or a mobile app or any other programs you can use it. So that this model becomes a artificial intelligence. So it started learning from the data and start predicting. Okay, so that is our first lab. Do you have any questions? You just try different things. That's how you will understand that and come up with more questions. So I already uploaded the program, so you can download and open in Jupyter Notebook and start try different things. Trying is not bad. Okay, can I go to the second lab? All right, so we are going to the second lab. The second lab is all about, we are going to teach the computer with a handwritten, the way of handwritten numbers. So when you see when you are depositing your check, you wrote the amount in the check. But when you start depositing the check, how the computer can, or the ATM machine can say, oh, whatever you wrote the number is 3 is 3 or 2 is 2 or 1 is 1. How can you understand that? So that's a similar problem here we are giving. So our data set consists of all those small binary images. So each one is an image. 0, this is one image. So you have 9 by 9 images, like that many different images. So we have a data set, MNIST data set they have given. It has 70,000 pictures, all different pictures. Like people can imagine, you put the 0 and 2 and any way you write it, the maximum number of different variations. We have a data set called MNST data set. And for each one, if you write the one this way and slanting way, or both sides slanting way, and it has a target value, categorical values one. Here, the categorical values are, the target values are categorical, and the result can be from 0 to 9. That's why it's a categorical value. Is this a linear problem? No, it is a classification problem, because the predicted value should be between 0 and 9. Okay. So I have a lab. I'm going to show you how to go through this lab. Again, follow the same process. So let's say, first, foremost, load the library. So we are only using these libraries. And what we are doing is, first import the library, what we use it. Like 5 steps I told you, import the library. And now we are, the data set, we are loading the data set. In this case, there are 70,000 records we have in different pictures. All those things are available from the MNIST data set repository. So for learning purpose, you can go to this module and see all the open ML data set, what all the data sets available, because there is a lot of data sets available. You can make use of it while learning, right? So in this example, what we did was, we are importing the data. X will have the value need to all the different small images, right? 70,000 of them. And then Y is where we are kind of predicting. What can be the Y value? It can be from 0 to 9, because it's a categorical value, 0 to 9. We are predicting, looking at the image, it can predict whether it is 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So the second step, what I said is importing the data set, okay? once we have importing the data set, you can just look at the data, because these pictures are coming as a binary value, right? So you can, in pixels, different pixels, right? So, and then just, how many we have, around 70,000 in the data set. And then what we are doing right now is I wrote a function here to having the pixel value and show what the value we stored it. So for example, here x of the first value we have, the zero will start from 0. So it is written like this, right? And then the first one is 0. The second one is 0. That the second, the third picture is 4. And the value of y4 is what? The corresponding value, right? The 2, value 2, which is going to be 4. So this pixel of value, the target value is 4. So we are teaching, if you got the picture like this, the value, the result is going to be 4. So we are teaching the model. So I just wanted to show you with this method how to use this, find the picture. And then I'm going to leave up to you to continue this program and fit the model for a logistic regression. So I have this lab up to where you have the data X and Y. So once you have the X and Y, you know what need to be done? Next one is create a logistic regression, just like our other lab we did. Logistic. So what we have to do, the next step is you can use the logistic regression here, like this one. That's the next step. Here, the next step is going to be like this. And then what is next? So what is the next step after that? You need to fit it. I want you to try, and I just leave it up to you. Once you fit it, then what is the next one is started predicting it. Then you start predicting it. Once you start predicting it, and then you can try different ways to see what is the probability and things like that. So I'm going to leave it up to you to try out this this exercise of how you are teaching the model using the logistic regression. Hope you all understand that. So logistic regression basically is a categorical value, and it's a sigmoid function. Things you need to, the takeaway for you. And the other thing is the difference between linear and logistic regression. I think we are kind of finishing these two, and next week we are going to have the tree and the SVG model. There are 2 more models we are going to learn, and we will end the supervised learning, and then we will go into unsupervised for the next session of classes. Now I'll open up to you for any questions. Narsi, you want to say something? Anything I didn't cover?
No, Venkatesh, you covered pretty much everything. I can just give one example what we are doing here when it comes to linear regression. So we are using linear regression for our anomaly detection and more passport validation. However, we found that some of the data that we get from smaller countries like Andorra or very small, tiny countries are there in Eastern European, and then we don't have enough population of their data. So this sequential model that we have, which basically looks at the passport numbers that are coming in with respect to the issue date. As you know, like most of the numbers are in sequential fashion. And then we are looking at whether this particular number that we are getting is issued during the same time period as the previous one, and try to predict whether it falls into the sequential model. We have found some deficiencies. In order to rectify those deficiencies, improve our modeling, we are looking at two additional models, two additional algorithms to improve our model accuracy. One is a quantile regression. Quantile regression is an extension of linear regression. That method, as well as we also did a study on isolation forest to see how isolated that particular number would be, how much it is away from the sequence numbers that we have seen. This is to say whether that particular passport or document that's coming from particular country can be a pass or a fail, based on the known historical data. So we are doing that. We did the study, we picked these two methods, and then we will be working on engineering effort, next quarter.
Thank you, Narsi.
Yep.
Yeah. Saravanan, is that getting clear? Do you want me to use something like a very simple terms, or because some of them are kind of more mathematical functions? So I try to explain it a couple of times, but hopefully everybody will get it, right, Saravanan?
Yeah, Venki. I think it was good. Yeah, more analogies are good.
Yep.
More examples are always good.
Yeah, we'll have more, I will put more projects so you can try yourself, and I'm going to give you a data set for training, and I will give you a separate data set for predicting, and you should predict that and send it back to me. I will create like a project you can try, and then I can see how well you did that. And you can also upload your program to see where you did. So you have to follow 5 steps. 1, importing the library, uploading the data set, create the model, fit the model, and start predicting it. These 5 things you need to understand, right? The rest of the things we need to do a lot of data exploration, but I will give you some exercise for that. And hopefully you all understand, but if you have any difficulty, please let me know. I can have a one-on-one class, because I wanted to see you guys are attending the class almost on every week. I wanted to make sure you understand the concept, and once we have this done, we will go to a real life models, and we all can work on coming with some prediction, real prediction. There's a lot of models available. We can take part in the competition also, and this will come in the leadership leaderboard. So it's a great opportunity to learn, and this is going to be the future. Every application is going to introduce this artificial intelligence, because nobody wants a static website. They want something. As soon as you come to the site, the site should be able to predict, oh, this is this person, and based on this and that, it will start predicting, and it will show you what you needed. If you are not able to give that functionality, your business may get affected with your, especially with your other competition from your business side. So this is going to be very vital. So learning this is not going to go into a waste, and it is going to be with you forever. These functions, just like some other languages, you keep learning, and that's get outdated, and then something new comes up. but these are the fundamental mathematical fundamentals from 1950s, and there's a lot of models are developed. It is going to get better and better. More people are going to use it. More digital data, the more data we get, we can teach the system a model, and it can predict a better way with all this data. Mani, anything you want to cover or mention? I think he may be in another call. Uma, you want to mention something?
Not from me.
Okay.
Yeah, I think pretty much it's a very good class today.
Yeah. So after this, we are going to get into more on AWS has its own machine learning, and that point of time, Uma is going to be teaching, and I will be a student that time because I'm going to learn from him. So learning is a never ending. Keep learning, keep your mind active, be confident. That's all about it. All right. So any questions, please send me an email or email is the best. Put the email into robotics4youth@gmail.com and I can answer the question. And if anybody needs an extra class to cover that, please let me know. Don't wait to explore more. Try set back at least, or 10-15 minutes a day to go through it on a daily basis. And your brain will learn all the things you do on a daily basis and keeps in your knowledge base. So, all right. Thank you for joining. Have a great rest of the weekend. It's already Sunday. So.
Thanks, Venki.
Thank you.
Thank you, Venkatesh.
Thank
Very
you.
good session.
Oh, thank you.